Okay, so we are good to go. So good morning, good afternoon, or good evening, depending on where you're joining us from today. From the Q&A and chat window, it looks like we have people from all over the world, so welcome everyone. And again, thank you for taking an hour out of your busy schedules to join us for today's webinar. So again, I saw that a few of you are joining us for the first time as a webinar, so welcome. And if you end up loving today's session, I will go ahead in a few minutes and I will share a link in the chat window where you can go and locate the first and second sessions of this programmability webinar series with DevNet series. Today is the third session of that series, software-defined networking and controllers. But again, for those of you who it's your first time joining, do not worry. You did not have to see the first two presentations to be able to follow along with today's presentation. So welcome again, everybody. Just a few things before we get started with the actual presentation. As Patrick is going along today and presenting, please use the Q&A panel to ask any questions. We do have Joseph on the call again. He's going to be helping answer some questions in the chat window. I'll be monitoring questions in the chat window as well. We will end the session with a brief 10, 12-minute live Q&A where we'll be calling out questions that y'all have submitted into the Q&A panel to Patrick. But again, everybody, I apologize ahead of time. An hour just is not enough time to answer all the wonderful questions that y'all have. In a perfect world, we would sit here for 5 hours with y'all and help y'all and answer the questions, but we just don't have the time. But we will try to answer as many questions as possible. We are recording, so a link to today's session will be sent out to all registered attendees via the email address that you provided at registration. You will also be able to find the recording along with a PDF version of the slide deck on the Programmability with Cisco DevNet blog. And again, I will share that blog in the chat window once Patrick gets started with today's presentation. At the very end of today's session, after it ends, you actually have to exit out of the WebEx environment for this to pop up. But if you could please take about 30, 45 seconds to answer a feedback survey. It's very brief drop-down menu questions. Please, we'd love your feedback, and I am always curious as to what topics y'all are interested in for future webinar sessions. So again, today is the third session of this series. We started off at the beginning of October with Networking with Programmability is Easy. The second session was just a few weeks ago on October 31st, and that one was a network engineer in the programmable age. And then today we have Patrick joining. He is going to talk to you about software-defined networking and controllers. Just a really quick update. In January, and the date will be posted soon, but keep in mind that in January we will be hosting the fourth session, Adding API Skills to Your Networking Toolbox. We realize that things are about to get really busy, everyone. If you're on a semester schedule, you'll probably have exams. The holidays coming up, we wanted to be aware of everyone's schedule. So again, the next session will be in January once things slow down again for everybody. So real briefly, I know a lot of you ask about the certificate of participation, so we'll go ahead and talk about that now. There will be a certificate of participation at the end of the series. Again, we don't do certificate of participations for joining individual sessions. But once this series ends, I will share a link, and it will also be posted on the blog where you can go and sign up for a certificate of attendance, participation, and then that will be sent out to you by the end of June. We are adding an extra bonus in here for all of you who are on the calls and watching the recordings as well. We will be raffling off a total of 15 Amazon gift cards in the amount of $25 US at the end of the series. We will be raffling off 10 of those Amazon gift cards to everyone who participates in all of the live sessions. So I know just from looking at the participation list before we got started that a lot of you are already qualifying to be in the drawing for the 10 Amazon gift cards. And then the last 5 of those gift cards will be raffled off to everyone who participates in all sessions of this series by either attending the live sessions or viewing the downloading recordings. So we know everyone has a busy schedule. Everyone's work and school schedules are different. We understand that you might not be able to join all of the live sessions, but you can definitely still enter in that raffle by watching the recordings of the sessions that you cannot attend. So we hope you find that interesting, and we hope that that drives y'all to join us and come talk to us. So with that, I would like to introduce you to Patrick Rockholtz, and I'm so sorry if I pronounced your last name wrong, Patrick. But Patrick is joining us. He is a Cisco employee. He's Atlanta-based. He's a systems engineer. He's been programming since he was 10, and he began getting involved with networking in college when working as a computer lab monitor. Since then, Patrick has gone on to work for a handful of service providers, starting as a network administrator and growing into a design and implementation role, responsible for a residential and commercial network of over 1 million users. He then began to move into the customer-facing sales engineering role to design networks for businesses, which led to his current position within Cisco. He loves reviving some of the program concepts he learned long ago and bringing them to this new era of networking and to help others learn the same. So with that, Patrick, welcome. Thank you so much for your great presentation today, and I will pass you the ball.
Thank you very much, Kara. Appreciate it. Everyone can hear me okay?
You sound great.
Okay, great. So for those who were at the last session, you heard a great presentation by Hank Preston. And it is always difficult to follow Mr. Preston, but I will do my best. And in so doing, we'll quickly review one of his slides that he presented. For those who weren't at the last session, this is maybe the first time you see this, but Hank really talked about the network engineering skill set and how that is changing and moving through these different phases. And so we're kind of moving from this Stone Age, a very simple layer 2, and then into layer 3, and then on into some of these more programmable pieces. And over on the right side is kind of where we want our final destination to be. And one of the great things about Hank is as he showed this and kind of touched on it, I want to kind of touch on it again as to why these changes are taking place. It's not just because we found new skills and we want to learn them, but they actually have some real value. So as we go through this introduction piece, I'll start with some businesses and some of the things that they're doing to transform themselves and make some things different with their business. And two things that really stand out for them. One is they use a network, namely the internet, to interact with their customers and continuously develop their applications and continue to innovate their applications. Secondly, they use what we call this DevOps model, this DevOps style of continually integrating, continually developing, and continually deploying new sets of those applications to their customers. So they kind of just always have that innovative touch point with them. And I'll kind of rehash this again. Is on the left we have what we would call, your traditional brick and mortar stores, places that have been around for a long time, but are starting to awaken to the idea that they also need to digitally transform and touch their customers in new ways. Home Depot is based out of Atlanta here, and so I'm familiar with them. But as they continue to increase their online presence and allow ordering to take place, allow you to pick up in the store or ship from their website, they're trying to integrate what they already have with their traditional stores with more of an online presence, with more of a digital presence, and trying to stay ahead of the game there. And on the right, we have some really interesting businesses that continue to disrupt in that digital space. A couple I like to call out is Netflix, for instance. Netflix started off as if you ever heard of Blockbuster Video, that was a store you go in and rent those videos, physical media. So Netflix said, why don't we ship the physical media to the customers? And then they said, why don't we get rid of the physical media altogether and just go straight to digital? So that's what they've done as they continue to pivot and change their business. Amazon's a great one to call out too. Started off as a bookstore. You can pretty much buy anything you want at Amazon today. Also, looking at this list, you have Uber. Uber basically transformed the taxi/ride-sharing business. They did so with basically an application that they just built a framework around and pulled in different sections of other people's data that has already been developed, namely some APIs, and we'll talk about APIs in a little bit, but pieces from Google Maps and so forth into their own application and disrupted an entire business. And one of my favorites is Apple, because you look at Apple and you see a company that's transformed from personal computers to the music industry, into phones, into wearables, and obviously rumored on maybe doing some cars next, but just a company that continues to try to stay ahead of the curve and continue to transform for what their customers desire. And all these companies are using the network to do that, using the network, and again, namely the internet and their applications through the internet to make those changes and continue to have that touch point with their customers. Unfortunately, one of the things that has not changed nearly as fast is the network. And it is still, according to this quote from Gartner Research, is still very much a manual process to go box by box and configure that network. And so what we have is from the business, as you say, we see this business pressure put onto the IT teams, the IT infrastructure teams, to make those changes, to become more business relevant, to be more inside the line of business, to help those businesses grow and get the data they want, so that they can stay ahead of the curve and stay with their customers and what they want and desire. So there's this business pressure on the network, and then companies like Cisco and other vendors love to bring out new products, hardware and software, new features. Unfortunately, that IT staff doesn't change a whole lot as far as the number of people, but a lot of times those features, again, I would call that an external IT pressure. There's some external pressure there to continue to add new features to the network, to look at new features, to have time to test new features that we might want to put on the network. So business pressure, external IT pressure, and then there's, of course, the day-to-day internal pressure of the network, that where constantly in our networks we're seeing more and more mobile devices come on. We're seeing more IoT things enter the network, whether that's helping manufacturing companies with monitoring gas lines or humidity and temperature sensors, or maybe it's something within a retail space to show how many people are in a store at a certain time. All those things are coming off the network, and so you have more devices, more IoT things, and of course, the more devices you add, you're also adding this last piece here, this growing threats. There's more space for there to be a security breach or a vulnerability. So this kind of brings us to what some of those challenges are for the IT group, and namely, it's become more difficult to secure with that complexity. We've added all of these parts and pieces, so there's multiple places to go to look at different dashboards and different monitoring. Operationally, there's different ways to go through CLI or GUI interfaces, all these places to go. So we've created more difficulty in managing all of these pieces. And of course, when you create that complexity, you also add to the complexity of troubleshooting and how to resolve these issues. And the traditional networks cannot maintain this speed and pressure from business and from external and internal IT. And so as we've looked at this evolution in the network, we kind of look at on the left side, this information era where data and voice and video kind of came together in this golden convergent sort of manner. And we were at one point, we're able to keep up, and we were able to go box by box, but that's no longer the case. And so we continue, as the innovation continues to happen on the business side, the innovation has to happen also on the IT side. We have to be more agile. We have to figure out ways to control the security. And so that's kind of where some IT groups even today kind of halt and not sure where to go. They're not sure where to go because do they want to first tackle the issues of business and helping the business innovate? Do they want to look at ways that they can assure what's going on in the network, the ways that they anticipate things to happen on the network, and so in that way try to figure out ways to reduce the complexity? Or do they want to tackle the security piece and the compliancy that has to go with so many more government regulations as well? So as they do that, we kind of move from this parts and pieces, right, these routers and switches. How can we take those individual pieces and elements of a network and move to a holistic, what we call a fabric of a network where all those devices, routers and switches, wireless LAN controllers, are all talking together, feeding this, as we'll talk about, this controller a certain policy, right? We create an overall intention in the network for it to function a certain way. And so this is what we're going to talk about next, and some of the ways that, some of the history of that through SDN. Now, for those who don't know, SDN is software-defined networking. The picture here is of the elephant because it has been defined in many different ways. And Cisco was actually one of the first kind of looking at this and exploring it probably 4 or 5 years ago through some different elements. We'll talk about those as well. But as we look at what SDN might mean, it might mean a separation of control and data planes. We'll talk about that as well in just a minute, and maybe some intelligence that goes behind that. It might mean taking the physical underlay and separating it from a logical overlay to create somewhat of a network that can, as it's separated logically, can be moved from a different physical networks underneath. So maybe we go from one service provider to another, the logical network would stay the same. Or does it just mean I can program my interfaces and push different scripts down to those to configure them? So this is kind of the way the network has always been. Every router and every switch has, as we say here, a control and data plane. So the control plane, if you think about that, is as you configure different pieces and parts like OSPF, EIGRP, some of those IGPs that might be on there. So that is the control plane. The control plane then tells the data plane how to forward those traffic, how to forward that data through its interfaces. And so symbolically here we have the brain for the control plane on each device and a small picture of Arnold Schwarzenegger for the data plane, the brawn of each device. So early on, and Cisco's involved with this as well, and so what if we could take all of the control plane and move them to some sort of central management? And that sounds well and good, because then we have kind of a central place that's communicating to all these devices, these routers and switches. The problem with this approach, though, is if we lose that control plane, that master control plane, all of these devices become, they cannot forward the traffic. They just become dumb routers and switches. So Cisco, looking at this and kind of working as they normally do, and can we do a best of both, right? There's a hybrid approach here. What if we could take a controller, a control plane controller, make that the big brain, and since we've manufactured routers and switches for 30 plus years with CPU and memory and storage, what if we could tell the controller to push these pieces down, and we'll call those little brains, to the routers and switches, and that way if something does happen to the controller, all of these devices can still forward traffic. So that's kind of this hybrid approach, and that's kind of where Cisco landed and said, this is where we would put our, ideally our controller, that we have some sort of application, something we want to tell the network to do, and we call that from a northbound, and we say here a REST API, and so that's a representational state transfer application programming interface. Cisco has lots of an acronym, so whenever I see one, I'll try to at least spell it out the first time. But all of these things into the network go into the controller. The controller can take those intentions and then translate those southbound to those devices, and those devices that are running iOS, iOS XE or XR, whatever those operating systems are, it can make that translation down to those devices. And so what we come up with in the very end is this ability to manage and apply policy across the entire network. We're able to do this at scale, because that's really one of the main problems we're trying to tackle here is the scaling of this. Sure, if you have a network of one router and one switch, sure, that's easy. That's CLI. But as these businesses grow, we want to look at ways that we can do this in a more timely fashion and in a more a way that's repetitive, so that we always know what we're getting, and then further be programmatic. Now, I mentioned APIs. I'll stop here real quick. Just a real quick, what is the API? It's a way for two pieces of software to talk to each other. So historically speaking, when you go to a website, say you type in www.cisco.com, and you get a response from that, that is a human talking to a computer to get that response back. The value of the API then is that instead of the human being in the middle of all of that, I have two computers, two machines doing that in the background. They're requesting information or changing information between each other without the involvement of a human, right? So I say here, if you remember, we talked about Uber in the very beginning, how Uber was able to basically look at some Google Map APIs and pull them into their application when you go and request a vehicle, a car, for ride sharing, that those maps you see are pulled in from Google. Uber didn't write that. Uber didn't drive around the country and get those maps. Those maps are pulled in from Google through APIs, along with other pieces in their application as well, are all kind of pulled in through different APIs and have created the application. When you open Uber, that's what it is. All those APIs are pulled together. So that's essentially what that means. So let's take a step further, and as we look at Cisco's overall traditional approach, moving into the DNA Center specifically. Cisco has called it the network intuitive, and the vendor agnostic term is this intent-based networking. IBN is what it's called sometimes. So I have some goals in my business, some things that I want to do in my business, whether it's making certain business applications a priority, or because of Cisco's partnership with Apple, maybe making certain Apple applications a priority on the network. I can do all of these. I want to do all of these things, and so I put that into the network. That's powered by intent. I want to do something, and then what DNA Center is going to do is kind of translate that onto the network, and push it onto that policy onto all those devices. It's also going to check to make sure that what we've intended the network to do is it's actually doing it, and that's that assurance piece there at the bottom, that it's always verified. This is a process of constantly learning, constantly adapting, and also constantly securing the network to make sure everything that we've intended it to do is actually doing it. So that's that powered by intent and informed by context. So here we have just a quick snapshot of some of the pieces that we'll get into here, and we'll do a quick demo here at the end. But this is the piece of DNA Center. Now it says Central Network Management System. I would challenge that a little bit and say that it is more than a management system, because it's the central place where I can go in and under the design pillar, if you will, the design elements, I can go in and sort of break out my network from a global scale down to maybe different regions or countries, or even cities in those countries, and then into buildings and floor plans, and break down my entire network so that either from a global scale or a regional scale, or however I want to do it, I can set up all of those parts and pieces that the network would require, whether it's AAA servers, whether it's DNS servers, DHCP servers, all those pieces I can kind of configure that. If I want the whole network to use all of that, that's great. At a global level, I can do that. But maybe there's different regions. May have a different regional DNS servers or whatever it is, or DHCP. I can do that as well, and the regional sections will override those global configurations. Also have provisioning. So there I can do my software image management. As those devices are found in the network through a discovery process, I have all of my devices listed with their iOS versions and all those pieces. And if maybe a vulnerability comes up or I need to upgrade certain devices to a new version of software, I can do that through a checkbox, tell it to deploy the software, and either do that immediately or I can schedule that for a maintenance window. Assurance is a piece we'll get into also, where that's that piece where the network is kind of monitoring and seeing what's going on in the network to help us keep the network healthy. And we'll see some of that. We'll dive a little bit more into that in the demo as well. The last piece is a policy. The policy is one where we are no longer talking in terms of just IPs and VLANs. I'll show you what I mean here. But now we're able to create policy based on maybe a group of people or maybe a group of devices. And then we're able to say this group can talk to another group. Patrick is an IT. He can talk to other IT resources. He may not talk to finance. He may not talk to HR. So what this is called is software-defined segmentation. That as Patrick joins the network, and what that can be through wired or wireless, whenever I join the network, it knows who I am and basically puts a tag on Patrick so that wherever I want to go, it knows the resources I am allowed to access and the resources I am not allowed to access. So that's what we're doing. We're kind of breaking away from the more traditional and historical VLAN and IPs, along with those crazy long access lists that we all know tend to stay around for the third and fourth generation of network engineer who has put in the 110th line of that access list, and nobody touches it because nobody knows why it's there or why it was put there originally. So we get away from that and into this, hey, whoever is joining the network, I know who they are, I know how they joined, I know where they joined, and these are the things they can access. Now what's nice about that is is that all those pieces are under what we call the Identity Services Engine. And again, that talks through APIs to our DNA center. So again, we have this communication from machine to machine so that throughout the campus fabric, we know what's going on, even from a security standpoint. So security is definitely top of mind here as well with DNA Center. This was an interesting study that was done, I believe it was an internal Cisco study, but it kind of went through, and we talked a little about these pressures that we have. And IT, there are tons of different pressures that we're getting from different components, like we talked about business, internal, external IT. But we also see that in the midst of all the things that we want to do and all these projects that we have on our plate, in the middle of all those things, and I've seen this in my customer experience as well, we always have this piece called troubleshooting. Doesn't matter what project you started, about 5 to 10 minutes in, there's usually a knock at the door from a manager or someone of importance who says, stop everything you're doing, this particular server's down and all of our customers are down or can't get to something, right? So as we look on the far left, these issues or tasks that we do, whether it's traceroute, and traceroute has always been a great tool. It's especially useful if you know every single IP address on your network so you know what devices they're hitting. But that can be hard sometimes. There's also the issues maybe of slow onboarding. And with slow onboarding typically comes this idea of issue replication. Because sometimes a person who onboards, by the time you get to the ticket and you call them up and say, how can I help you? They say, oh, I'm fine now. And so it gets dropped, and there might be a problem that just is an intermittent problem that could be resolved, but we just don't have the time or the resources to go back in time to find it. So there's kind of a way that Cisco took some of these things that DNA Center could help with versus the traditional approach and said we could get back 90 days a year based on this troubleshooting cost. Now, whether you believe the 90 days or not, I totally understand, but maybe it's 60 days, maybe it's 30 days, maybe it's 1/3 of this. That's still a month out of the year that you can get back if there's ways that DNA Center can help with troubleshooting, and I believe it can. I think this is the piece that we talked about, this DNA assurance. This is where all of the devices we have are already collecting all kinds of data, and we can take that data into the assurance piece of DNA Center, look at some different ways that all of those things can correlate together, and sort of present some suggested remediation. Now, some people call this tack in a box. That as this assurance piece grows, and it's now, I think it's over 150, it says here, insights, but that will continue to grow based on, the 30-plus years that the Technical Assistance Center has really helped troubleshoot all of these pieces and parts. And we'll see that a little bit in the demo. There's one last piece I'll call out, DNA Center platform. So this is where DNA Center has opened its APIs so that whether it's a third-party company, let's say a ServiceNow, can communicate through DNA Center and help us out in those ways, but also we can create our own scripts through Python and other types of programming languages to help us out as well, and so those APIs are open. If you were familiar with APIC-EM, sort of the 1.0 version of DNA Center, you may have already seen some of this as well, and I believe that's a lot of the topics that we're going to be talking about in January. Let me go back to ServiceNow real quick because this is an interesting use case where, let's say on your network you have a device that has a bad power supply. Well, that bad power supply, DNA Center can be notified of that, and through these APIs and these third-party integrations, we can then, through ServiceNow, create a trouble ticket. Not only create the ticket, but we can also notify TAC on the back end so that when you get in, say, the next morning, there's a box sitting at your desk for, this new power supply, and here's, the ticket's been generated, so what you do is go in and replace that power supply and close the ticket. So these are the types of API chaining, if you will, that we can do through DNA Center now. And all of this will continue to expand as more and more partners join us in this journey. So let me quickly, I'll stop right here if there's any questions, but also quickly get the demo up and running. Do we have any questions right now?
Sorry, Patrick, I had myself double muted. So I think I only see one question, and it was the question is, will the SDN controller provide a single point of vulnerability?
Yeah, so that's an interesting question. I think as far as the hardware goes, the DNA Center is actually made up of 3 UCS C-series servers, and that's, again, so just like on the data center side, we kind of do the same thing with our ACI controllers. We have at least 3. That way, if one does fail, we have a way that it can still function and still push those policies out to the network until that one has been replaced. And then also, like I said, even if everything was lost, the network would continue to function in its last known state until those controllers were brought back up and can communicate again. Does that help answer the question?
Thank you. And it looks like Joseph is answering the other question. So there is one more question. It says, what happens when CPU-based SDN supercontroller crashes versus truly stable and expensive traditional hardware-based redundant network? How do you compare the cost of the design and the time to recover of one versus another?
That was long. Could we repeat? Can you repeat?
Yeah, that is long. I'm sorry. Okay. It is long. How about we have Joseph answer that one because it is a little long.
Okay.
That way he can read it and answer it.
Okay. Let me just to say, I'm going to get my screen back here for just a minute while I'm trying to get back over to where I was. Let's see. Share content. Share. Okay. Let's see if I can get back. Kara, let me know when you can see my screen again.
I can see it.
Perfect. So I want to take you guys quickly into, this is one of our DNA Center demos. And you can see kind of how it's set up here. In the very beginning, we have some nice health summaries, and typically those are percentages. And then we have some additional pieces about just information about our network, devices that might be on there, the images we've created. And there's the 4 elements we talked about before, whether it's design, policy working through our identity services engine, provisioning, some of our software image management, and then this assurance piece as well. And then, of course, we have the tools at the bottom, whether we're discovering for the first time the overall campus fabric, gathering the inventory, looking at some topology. All those pieces are here at the bottom as well. So let's say I wanted to just dive right into assurance and take a look at that. And what I see here is again, just some overall snapshots. And one thing we do notice right away is, wired is 100%. Wireless is 83, but some of the other issues that might be here, these top 10 issues, we might see right away that we might want to jump into and kind of see what the severity of those are. And if we click on them, we're actually given, in this case, this OSPF adjacency, we're actually given some suggested actions. In order, one is to try to ping the neighbor, and it's actually telling what interface we need to ping. And if this did have the other side connected, we could hit run and it would do the same thing. But as we go through here, we can see that there's ways that we can, check the OSPF neighbors, given that this particular command and so on. We can basically work our way through some of these suggested remediation points to help us get this adjacency back up and running. And that certainly is great from that standpoint, but maybe it's something within some of our clients. Maybe some of our clients are having issues. And again, like we said here, we see, in this case, a 24-hour snapshot right away, but we can certainly change that. And this is one of the pieces I talked about, how, in a typical network experience, if you go back, if you see a ticket and you go back and call that person or reach out to them, they may say, everything's fine. We can jump back. We can use this network time machine, if you will, to go back and even look at, in this case, a quick 7-day snapshot of what our network looked like and sort of look at some different pieces there as well. This also gives us some additional information around the wireless components, the client onboarding times, if those start to get slow or there's some lag there. And we can also see some of those devices that are on our network. What's really nice about this is, let's say there is a particular a user that's having issue. Let's say it's old danger-prone Daphne again, right? So we can basically start to look up Daphne and see from a user standpoint what's going on in her network. She's called before. Definitely had some issues, and maybe we want to look at what those issues might be. Maybe it's from Daphne's PC that she's had the issues. And we do see some times in here where we see definitely some dipping down on her network connectivity for this particular machine. And we also see some other pieces here. Path trace is one of the carryovers from APKM 1.0, which is a nice graphical way to look at, as we said before, that trace route information. We can also see quickly as we highlight some different pieces what her IP address is and how she's basically coming on to our network. So we get some pieces there as well. As we look at, we see there's 8 different issues, but maybe the issue was maybe around this spot over here, right? This particular area. So I can scroll out here. So we thought we had 8 issues. I wonder if that goes down to 4 issues basically. So we can also eliminate the number of issues it shows us just by kind of pointing out a particular area that might be problematic. So as we look here, there may be some, this is all network latency related, but it could also be related, and maybe it's related to Outlook, right? So there's actually an Outlook web services called out, this application. So that's another piece that's continuing to be developed within DNA Center, is not only from a device health or a user health, but even application health. There's probably not enough times that we thought about where someone comes and says it's the network and it is guilty until proven innocent on the network side. This is one of those cases where we may be looking at latency of an Outlook service that has nothing to do necessarily with the network. It's outside of the network, but we can see that with some of these graphs and some of the ways that we can look at our individual health of the network. As this continues to get built out, you'll see more and more applications getting added to the application health. So we can see how applications are actually running across the network. Were there any other questions so far, Carrie?
There are, Patrick. I don't know if you want to take them now or if you want to wait till the end. There's quite a few rolling in now.
Okay, so yeah, this would be a good time to take some, especially if it's demo related. We can try to find those in the demo maybe.
Let me go through here and see if I see anyone that are about the demo. So there is a few students have actually asked this question. Can you please explain what DNA stands for them?
Sure. DNA stands for Digital Network Architecture. And I apologize, I tried to do my best to catch all of the Cisco and acronyms I could. That's one I missed. So think of DNA started probably about almost 2 years ago now. The idea being, and you kind of saw the one slide I had where it looked at some different things within the network that we want to look at, whether it's the insights and experiences from a user standpoint, how the user is experiencing the network, or whether that's ways to reduce cost and complexity through automation and assurance, or whether it's through making sure the network is secure from also reducing risk from a security and compliancy standpoint. So whether that's continuing to innovate with new experiences, or whether that's reducing cost, or whether it's reducing risk within the network. That sort of was the idea behind this DNA digital network architecture framework. We'll call it a framework because I think that's the best name for it. It's not truly an architecture, but it's a way to look at the network in a way that, what are the things that I can do within the network to help those out? Again, through whether it's from the line of business and they need some additional insights, through something where even some of our APs can gather information within, maybe a retail store to see customers that are standing at a couch for 5 minutes and maybe putting something on their phone saying, hey, we noticed you've been standing at this couch for 5 minutes. Do you need any help with it, right? So some of those location analytics, that's part of that experience. Or whether it's, part of the experience might be temperature and humidity controls for a manufacturing who needs to keep things refrigerated or frozen. And we have some of those customers even here in Atlanta that have customers that are counting on these large warehouses to store things in a controlled temperature, and so historically they've always just had some guy in a clipboard walking by row to row, writing down something on an analog dial or what the temperatures are, and maybe one day he decides that he doesn't want to get up out of his seat to go do that. And so he just writes down the temperatures on his clipboard and continues to watch whatever he's watching on TV. Lo and behold, those temperatures are really higher than he wrote down, and now that company has lost thousands of dollars worth of product. But through some of these pieces, some of these IoT sensors and pieces that we can bring onto the network, now we have a way to actually actively monitor these types of things, actively monitor the health of the business. And like we said, ways to reduce risk, right? We talked about some of this assurance piece right here that we're looking at through DNA Center. The ability to look at, is it an application issue? Is it an ongoing issue with a user who's not able to authenticate properly because the passwords are wrong, or maybe she wrote the password wrong, right? So all these pieces are helping us eliminate hours of troubleshooting when we can be doing the bigger projects for the business. And again, like we talked about also with security, the idea of wrapping around security as more and more countries and governments are putting compliances on what can and cannot pass through across borders, but also just the standard compliances, whether that's health compliancy or whether that's PCI compliancy for credit card information. A great example there is around the HIPAA compliance, which is healthcare. Maybe a doctor is using his tablet, maybe his iPad, to go and put patient records on there so that he can go from patient to patient, check them out using a digital format, keeping those records digitally, which is great. But obviously with HIPAA compliance comes the fact that he's not really allowed to take those patient records outside of the hospital. Well, with some additional location analytics through wireless APs, et cetera, we can make sure that if that iPad did ever leave that hospital, that those patient records are automatically deleted. So they don't leave the hospital, and then the hospital does not get a large fine. So it's just all of those pieces coming together through this structure, this framework, if you will, of the digital network architecture. Hopefully that explains a little bit. Does that help?
Thanks, Patrick. Did you want to continue with the demo, or do you want to take a few more questions?
I can take a few more questions. I mean, we kind of wrapped up the assurance piece, so I'll take some more questions.
Okay. So the next question was, does the DNA Center replace the APIC and APIC EM, or do you still need both solutions?
So let me go back. That's a good question. So going back over to our main page here on the DNA Center, and at the very bottom here, some of these tools you see, like Discover, Inventory, Topology, if you've used APIC EM, these tools probably will ring a bell because they were an APIC EM. And we'll call that APIC EM, which is kind of the 1.0 version. I would say that DNA Center is the 2.0 version without actually calling it APIC EM. It is now considered DNA Center because it can pull in so much more than APIC EM could. And by that I mean with some of those open APIs we saw, that we can now bring in things like the Meraki dashboard, right, which is a different product altogether than our routers and switches that Cisco's main line of routers and switches. But now we can start to integrate through those APIs more and more different management pieces as well as operational pieces together in one place. So like we talked about before, if I can reduce my complexity by having one place to go, namely DNA Center, and can pull different elements, and I also mentioned this, that some of those devices that we can start to pull in, Cisco's creating third-party or other vendor ways that we can pull in from non-Cisco devices and report some of the same information that we have with Cisco devices into DNA Center. So even if it's a pure Cisco environment or maybe it's a hybrid environment, we can pull all those pieces into one dashboard.
Thanks, Patrick. And I'm just trying to find the questions that Joseph has not answered. He's doing a great job.
Thank you, Joseph.
Let's see. Man, Joseph, there must be like fast fingers over there. Okay, so Joseph, here's another question. How are the policies implemented on the network devices? Does it still compile ACLs and VLANs, or is it completely hidden?
So I think some of the policy that you would see is IP still exists, right? There's still, even in DNA Center, there's ways to look at IP management and so forth. You can still access it through there. But as far as the policy, let's say a user onboards to the network. Again, we saw even when we were looking at Daphne, there's definitely IPs on those devices, but there's also, in addition to that, some what we call SGTs or scalable group tags. And that's what I was referring to when I said, Patrick joins as an IT person, signs in as an IT person. I get, this IT tag, Patrick's IT tag that follows him whatever he's trying to access. And so if I try to access some financial, servers, those would be in a different group. Those would be, the finance group. And so based on some of these policies that we can set up, we can say Patrick can indeed access IT, but he cannot access financial group resources.
So Patrick, the next question is, what about the infrastructure? What are the requirements to implement SDN environment?
Sure. So, we talk about campus fabric, and one of the first, kind of overall forays into this is through some of the Catalyst 9000 access switches. So that's kind of where most of it starts, and they call that they call that software-defined access because it's basically DNA Center plus the Catalyst 9Ks, and that's sort of where a lot of people are starting building that campus fabric, because basically with that I can, at least from a wired perspective, immediately start to assign ports on switches to those, like we said, assign them to different policies. So that maybe, like I said, if I'm plugging into a Catalyst 9K switch on port 10, and that's set up for IT, and I log in and say, yep, Patrick's IT, he's definitely allowed to use this port, right? So then that port is kind of given that assignment, and then I can go in and access those particular groups. So that's kind of where a lot of it has started, was taking DNA Center plus the Catalyst 9000 series switching.
So Patrick, there's a question, is DNA compatible with SolarWinds software?
So I would say that I've not seen any direct implementation yet, but like I said, there's a lot of eco partners coming in because of the DNA platform piece. We've opened up a lot of software developer kits. We've opened up a lot of APIs. So potentially, and again, I don't know if SolarWinds products as well, but potentially if they have some of those open APIs, then I would say that certainly there could be some integration between the two.
Thanks, Patrick. And then another student asks, so can we say that DNA is a monitoring tool?
Yes. I would say it is certainly a monitoring tool. I would say that, based on what we've seen with assurance, it could be even more than that as well. That as we look at, again, some of the pieces that helps us resolve issues as well, absolutely. Now, another nice thing about this tool is that because of those APIs, again, we can start to integrate, even if anyone is familiar with some of our collaboration products like WebEx Teams. WebEx Teams on the back end, we can use some calls there as well and integrate it with the APIs here. So even if we're in a team space, we can call to our DNA Center and even get some information back from there as well.
Thanks, Patrick. So there's two questions. You called the DNA Center a controller. Can you elaborate on the type of software that the DNA Center is, like Network OS or something like that?
Yeah, so I used to know from the APPM standpoint that there was a Grapevine underlying operating system that allowed it to scale very well. It is no longer Grapevine, though I don't remember the under the hood name for it, but it is a scalable written out platform that allows it to move both as you continue to add products to it and continue to add devices to it, it can scale out very well. It is, again, like I said, it is run on 3 UCS C-Series servers, and a lot of that is also to help collect some of this assurance information.
And then, thank you, Patrick. And then the student's second question is, what are the competitors of the DNA Center?
Ooh, so that's a good question. Offhand, I don't know. I do know that other vendors have, kind of announced their controller-like products because they do see the need to get into the space. And again, that's kind of why I mentioned the vendor agnostic term intent-based networking, because other vendors will use that same term, that IBN term, to talk about their campus fabric as well. I would say, though, that based on what I have lightly seen on some of the other vendors' products, that this assurance piece far and above sets them apart, sets us apart from them, in the sense that we can go in and see so much and get so much data based on our 30 years plus experience of troubleshooting networks.
Thanks, Patrick. And I just want to double check, are you still good on time, or do we need to move on for a few minutes?
No. I think that's pretty much all I really wanted to cover as far as the demo goes. I will flip back over to, I think I did have some additional slides I'll kind of wrap up with here. Let me pull that up. All right. So yeah, just kind of mentioning here what we basically, overall we talked about were some of the problems that we were trying to solve from, a traditional network standpoint through the software-defined networking and more specifically Cisco's DNA Center, and given some of that brief history of where that came from. And then also some of the ways that through assurance and other pieces that DNA can help solve some of those troubleshooting issues. I also had here just a quick slide on some of the starting points. There is a DNA Center Sandbox, and as I share these slides, those will have the username and password for you to get in and start playing around. It may look a little bit different than what you saw here. That's because some of these different pieces are still being upgraded to the latest, greatest versions. Also wanted to quickly mention that on DevNet, there's some pieces there you can go through on DNA Center, some learning labs as well. And then there's some great Cisco Live pieces here. And again, for those that don't know, Cisco Live is sort of our free education from Cisco Live. When they're recorded, and then you can go back and watch them later with the presentation decks as well as the video usually. And so I called out some of those, one particularly on the platform itself, and then just some overall on the DNA Center and how to do some automation there. There's also a DNA software demo series that is ongoing. I believe I can't remember if it's weekly or monthly, but the information is there for you to look at if you want to see a quick demo, and there's another place to ask questions about it. And that does, in fact, pretty much wrap up what I have.
Okay, awesome, Patrick. I just wanted to make sure we had time for your wrap-up slides. Do you mind answering a few more questions since we have a few more minutes?
Absolutely.
Okay. Again, just trying to find what Joseph has not answered.
Thank you, Joseph.
What is underlay SDN and overlay SDN?
So when I describe that, the underlay network is actually the physical network, and then the overlay network is sort of the logical piece of that network. And I'd say this, that for those who are familiar with DMVPN, that's sort of how all of this kind of started. So basically, I have a physical network, and maybe one of my service providers provides that to me. Let's say it's AT&T, and we can build a logical network over that physical network. So basically, the logical piece is where our network's actually running, and it's using the physical network for that transport piece. But let's say our service provider is now asking too much money for us to stay with them. We could move from AT&T to another service provider without having to redo that logical piece. So all we really do is we change some physical connections or some physical layer, IP addressing. It doesn't really make sense, but from the physical standpoint of changing those IPs to a new service provider and keeping our overlay network exactly the same.
Thanks, Patrick. And then the next question was, what is the difference between home use OS and network OS? Are they the same?
Home use OS?
Yeah, I think between home use operating system and network operating system, are they the same?
I'm not familiar with that. I'm sorry.
Okay. No, I just wanted to, I wasn't either. I just wanted to see if, Favor, could you go into more detail on what you're asking about meta network, please? So Victor's asking, DNA Center seems very useful. Which programming languages support the command runner tool?
So as far as programming languages, I would say that Cisco as a whole, and I would say kind of, I'm shotgunning approach here, but I would say 80% of what Cisco is doing in programming languages centers around Python. And so that's another topic that I think we're going to touch on in January as we look at APIs and some ways to interact with those APIs. We're probably writing some simple Python scripts also to call against something like a DNA Center, right, where we're basically taking that Python code and running it against the APIs that are inherent to DNA Center.
Thank you, Patrick. And then, okay, so here's the clarification. What does a meta network mean?
A meta network? I mean, just from not knowing the term, I think it would be kind of, it sounds like it would be similar to what we're calling the campus fabric, which is basically no longer individual routers and switches, but is looking at the network holistically so that, again, all of the routers and switches are communicating to that controller, and then the controller, again, is pushing out intent to those routers and switches, and basically, in that sense, would be a meta network. It would be one campus fabric doing all of those pieces as it talks to a centralized controller.
Thanks, Patrick. He said that he saw it on Wikipedia under the DNA section and he didn't understand it, so thank you.
Yeah, no worries. That's what it sounds like to me, the holistic view of the campus fabric.
So, Patrick, is there any vulnerability of data integrity or hacking attacks within the SDN environment since SDN is virtualized?
I would certainly say that any device or any controller, we are human, and in that sense, programming will never be perfect. So I would say there will always be some sort of vulnerabilities and weaknesses that can be exploited. However, from what I've seen, Cisco is definitely determined to keep those as minimal as possible, given their, I can't remember what the number is now, but it's definitely over $3 billion in investments. And then the latest investment with Duo is another, I think, 1-point-something billion dollars. Cisco's approach is to, again, this goes back to some of those API pieces too, right? That as the security products, the security portfolio at Cisco becomes more programmatic as well, that there'll be more and more touch points between the security architectures and this DNA Center piece that, again, we can look at pushing back and forth across routers and switches. Maybe our Tylos group sees a vulnerability immediately and can notify DNA Center, and DNA Center can turn around and take that patch and push it out to all of our routers and switches as needed based on different versioning. So as DNA Center starts to gather more and more of that information across the network, now we have more information and more ways that we can go out and remediate faster, and I would even say faster than other vendors and other competition, because we have all of those products in place and all those APIs in place.
Thanks, Patrick. And guys, we are running out of time, so this is going to be the last question. But again, we will try to do our best to answer a few more in the chat and Q&A window. Patrick, can you give examples of SDN-based enterprise or home network automation solutions like the Cisco DNA? And actually, Joseph just answered that with take a look at Cisco Meraki. Joseph, you're fast.
Yes. And again, that was what I mentioned before, is Meraki is a great line of Cisco products. And with Meraki's APIs as well, we're able to bring in some of their dashboard information into DNA Center. So again, the idea here is that we have one place to go for monitoring, for operations, trying to make the life of a network engineer as simple as possible. Remove a lot of the complexity, but also increase some of those automation pieces, get more information about the network in one place so that we can do our jobs faster and better.
Well, thank you so much, Patrick, for answering so many questions for us today.
Yes.
I know that majority of the questions did get answered, so again, thank you. I know you answered quite a bit today for us. Guys, I am going to wrap it up because we are at the top of the hour. I know everyone needs to get back to their busy, busy lives. But again, I'm not going to try to find the slide right now, but I will just tell y'all, please remember that the next session, session 4, will be in January. I will email everyone out the date and the registration link once that's available in case you're interested. You don't miss out on that session. So again, I will email that out to everybody who has registered for today's session. And again, that session is going to be adding API skills to your networking toolbox. And Patrick, if my memory serves me correct, are you the speaker on that?
That's the rumor.
Okay, that's the rumor. Okay, guys. So hopefully you enjoyed Patrick's session. I know the feedback so far in the chat privately has been wonderful. So again, join Patrick again for another session in January. And I hope everybody has a wonderful rest of your morning, afternoon, or evening. And we will talk to everybody soon. So thank you, everyone. And thanks again, Patrick. Thanks, Joseph, for answering questions.
Yeah, thanks.